Calculus Kids, this is Dr. Callahan with Week 14 Tuesday. How are you guys doing? Go ahead and pause the video to answer the following 3 questions for your warm-up vlog. All right, you guys, go ahead and take a look at the foil of question number 3. All right, let's go ahead and get started with today's stuff. So this is week 14 Tuesday. So this is the last day for you to do unit 30 on differentiation techniques. So you could pick any 30 questions right there for your homework. Then after that, we're going to move on to week 14, Wednesday, Thursday, and Friday. Make sure you're really reading the Princeton review, which is important, especially if you're not understanding how to do the questions with Albert I.O. And then we'll finish up these 2 units, unit 3 and 4, applications of derivative velocity, acceleration, rate of change, by Sunday, week 14 at 11:59 p.m. And then after that, we're going to start off with unit 5, which is on derivatives, maximum, extrema, concavity, and then finally we'll end up next week with your first exam on the AP practice exam for the first one. All right, so let's go ahead and get started. So first thing I want you guys to do is take a look over here at the formulas, which is in your back of your guided notes on week 14 Tuesday. And I want you guys to go ahead and have 2 highlighters. So you can use the first highlighter as yellow, and I want you to go ahead and highlight all the formulas you already memorized. Next, I want you to use another highlighter. So in this case, I'm going to use green, which you can't really tell as well. So let's try this green. There you go. That's a little bit better. And I want you to go ahead and highlight the ones that you kind of know, but you're not quite sure. Maybe you need a little bit of additional work. And the very last one, the third color, go ahead and highlight the ones that you definitely need to memorize. Okay, and so then what I want you guys to do this week is that I want you to kind of start off here with week 14 on Tuesday, Wednesday, and Thursday to kind of memorize the ones you kind of know, but you still need some work on. And then end this week with week 14 on Friday, Saturday, and Sunday, and try to understand the ones that you definitely need to memorize that you certainly need more assistance with. All right, you guys, I have actually one more thing that I need to show you guys beforehand, and it is actually on integration by parts. This is also like a BC skill, but I figure that I wanted to show you guys this because sometimes on the AP exam, they do show like the very basic of this skill set, and I just definitely didn't want to miss it. But if you don't know it, that's okay. We'll go over the basics of it. And if you feel like it's too difficult, when you guys go to BC, they will talk more about this specifically. So with that said, let's go ahead and get started. Have you guys take a look at the steps and also the formula so that way you're well acquainted with it. All right, let's go ahead and take a look at the first example. So here's the example. It's x times e to the x dx. And so step 1 says determine the u value by using the acronym LIPIT. And it shows a priority for order of determining the u value. So log, inverse, polynomial, exponential function, trigonometric function. And so in this situation, we are going to use LIPIT to determine the priority. Okay, so we're going to go ahead and say let d be the other functions, find u, dv, v, and dv, plug into the formula to integrate. All right, so we're going to say u is equal to x, and v is equal to e to the x. Now, you guys know that the formula is as follows. So the integral of dv is equal to the integral of e to the x dx. All right, well, let's find the specifics of this then. So then du is going to be 1 dx. Derivative of v is just e to the x. And so now that we have found u, dv, v, and v, plug it into the formula and integrate. So I'm going to go ahead and plug it into this formula here specifically, which is going to be equal to u times v. So u times v is x e to the x minus the integral of v du. So the integral of v is e to the x, du is dx. So then we'll just have to integrate this tiny little piece right here. So looking at this part, what is the integral of e to the x? Well, integral of e to the x is just e to the x. So then my answer in this situation is x e to the x plus c. Or if you would like to factor the e to the x out, you can have x plus 1 plus c. And that is your answer. And that's integration by parts. All right, let's take a look at example 2 then. So looking at example 2, determine the u value by the acronym. So we're going to have u be x, and we'll have v be secant x. Because I know the integral of dv is equal to the integral of secant x tangent x. And so then let's find the du. Derivative of x is 1 dx. The derivative of v is going to be secant x tangent x. So then let's go ahead and plug this into the equation right here. U times v is going to be u times v, which is x secant x minus the integral of v times du. V is secant x times du, which is dx. Then I just need to integrate this teeny tiny little second part right here. The integral of secant x is going to be ln secant x plus tangent x plus c. Don't forget your first part. And this right here is your answer. All right, let's go ahead and take a look at example 3. So for example 3, we're going to say let u be x, or actually let's let u, it's going to be the ln, just kidding, ln x which means that your du is going to be 1 over x, because the derivative of ln x is 1 over x dx. You know that the integral of dv is equal to x times dx. So as such, we're going to have let v be x squared over 2. So then let's go ahead and plug this in. So your first part is u times v. So u times v is going to be ln x squared over 2. Minus the integral of v times du, which is going to be v times du, right there. So I'm going to have x squared over 2 times 1 over x dx. And now you can see specifically why I allowed to have v be x squared over 2, because this way I can cancel this part and I have an x right there, which means I can rewrite this as a 1 over 2 integral of x dx. And the integral of x is going to be a 2 over 2. So I will have a negative 1 over 2 times x squared over 2 plus c. And in which case, this can be simplified to negative x squared over 4 plus c. But then don't forget your first part, which is going to give you x squared over 2 ln x. And this is your answer. All right, let's go ahead and take a look at example 4. See some. All right, let's take a look at example 4. So for example 4, we know that you have the integral of ln x dx. So looking at this part right here, I know that the integral of ln x times 1 dx, and I know that the integral of dv is equal to integral of dx. And so as we go ahead and figure out we're going to let u be, we're going to go ahead and say let u be ln x, v will just be x, and then your du is going to be 1 over x dx, and then your dv is just going to be 1. Technically, you actually don't use the dv, but we'll find it anyways. So now that I have these 4 components, let's do u times v. So u times v is x ln x minus the integral of v times du. So v times du. So x times 1 over x dx. And the reason why I want v to be x is that so I can counteract with the 1 over x dx. So that way I can cancel it and make this a little bit easier to integrate. So this part over here really becomes the integral of 1 dx, which if you have the integral of 1, the integral of 1 is just going to be x. Don't forget your x ln x. So if you factor it out, you can have an x times ln x minus 1 plus c. And that is your answer. All right, you guys, let's continue on with example 5. Okay, so there are 2 different methods of doing this. For example, 5 and 6 and 7 and 8, I'm going to show you guys the different method of using this, which is called the tabular method. So take a moment and read this part right here. All right, so let's take a look at this. We're going to say let u be x to the 4th. And then I'm going to say let dv be sine x. So then I'm going to rewrite this with the integral of sine u which is equal to negative cosine u plus c. And the integral of cosine u is going to be sine u plus c. So those are the things I already know initially. So then let's go ahead and take a look at the tab method. So I'm going to create this part right here. We're going to have u on the left side, dv on the right side. And so then we're going to have a positive u, which is x to the fourth. I'm going to start off with that. Now I'm going to do the derivative of this, which is then going to become a negative 4x to the third. Derivative of this, you're going to change it to a positive 12x squared. Take a look where it says alienated signs. That's why we're changing it back and forth. Negative 24x. And you want to keep going until you have 0. So you want to keep going until you get to 0. So then positive 24, and then finally negative 0. And then after that, you can just stop. Now you're going to do the same thing over here for the dv. dv is sine x. So you're going to go ahead and do the integral because it's a dv, so it has to be integral. Integral of sine x is going to be a negative cosine x. The integral of cosine x is sine x, so negative sine x. Integral of sine x is a negative cosine, so double negative makes it a positive cosine x. Integral of cosine x is going to be a positive sine x. So with this one, make sure you do alternating opposites. And then integral of sine x, again, is cosine x, but with a negative. So you stop right there because, again, everything is aligned together. So then you just simply, your answer is going to be the diagonal of this. Diagonal, 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 diagonal. So looking at this, your answer is x to the fourth times negative cosine x is a negative x to the fourth cosine x. That's the first one. Second one, negative 4x cubed times negative sine x is going to give me a positive 4x cubed sine x. Third diagonal, 12x squared times cosine x is a positive 12x squared cosine x. Fourth one, negative 24x times sine x is a negative 24x cosine x. Fifth one, 24x times negative cosine x is a negative 24 cosine x. Plus C. And it is integration by parts with tabular method. And so this right here is your answer. I know it's a very long answer. All right, let's take a look at example 6. I'm going to have you guys go ahead and try this one on your own. So pause the video and give it a try. And then go ahead and take a look at the answer right here. All right, let's take a look at example 7. With example 7, you're going to let u be ln x. And going to be dv is in the x cubed. Derivative of ln x is 1 over x dx. And v, the integral of dv, which is the integral of x cubed, is x to the fourth over 4. All right, so then I'm going to go ahead and plug this in. So the first thing I have is going to be u times v. So then I have ln x, x to the fourth over 4, minus the integral of v times du. So that's x to the fourth over 4 times 1 over x dx. Now I know that this part will cancel. So I have minus integral x to the third, the 1/4 you can move to the left, dx. Integral of x to the third is x to the fourth over 4 plus c. Don't forget your second part. So my answer here is x to the fourth over 4 ln x minus 1 over 16 . Okay, my pen for some reason, oh, there we go. 1 over 16 x to the fourth plus c. All right, so now that I did this one, I'm gonna have you guys try example 8 on your own. And here are your answers for example 8. All right, you guys, as always, I hope you have a wonderful week, and I will see you guys next time. Take care.